All right, there it is. So this problem is a pure calculator problem. You want to go to normal, get normal CDF out. And that's under second stat, which is really distributions.
Gotcha.
And then it's the lower, it's the upper, it's the mu, and then the sigma. So in your case, it's normal CDF minus 0.82, comma, 1.2, comma, 0, comma, 1. So whenever you have Z, your mu is always 0 and your sigma is always 1.
Oh, so that's with, okay. Because that's what was my question, is like what to put for those two.
Yeah, so you know the answer for those. If they tell you the mean, they tell you the standard deviation.
But if they don't, do I just assume it's 0 and 1? If they put Z,
If it's Z, yes.
would they ever do that with like X and put X in the middle and then you have to find it?
Not they have to give you mu and sigma, or they have to give you enough to be able to find the missing variable.
Gotcha, that's easy. And then for like 33 through like 36, is that all the same gig? Because it gives you the mean and the standard deviation. So
Yeah, 36 is slightly different, but 33 is just like we did.
okay.
34 is just like we did. 35 is just like we did. Although on 35, I don't remember if, okay, so on 35, it's asking, well, I'm sorry, 33, it's asking below. So you have to know what to put in the lower position. And that may not be clear. I mean, we've talked about it, but it's still just, it's kind of ambiguous. So like here it's normal CDF, and since it says below, so that's less than or equal to 450, that's your upper, and your mean is 500 and your standard deviation is 100. But the question is always what to put here. Now, some instructors tell you like minus 10 to the 99.
Oh, it's that thing.
Which does work. It's excessive, but it does work. So if you want to just do that, that's the most straightforward way to do it.
Okay. So it's just like I would do that if they only give me like one, if they only give upper or lower.
Right. So like with 35, it's above 600. So your lower is 600. Let me snip this in. Normal CDF, because it's above, so it's greater than or equal to 600. So it's 600, comma, 10 to the 99, comma, your mean is 500 and your standard deviation is 100.
Gotcha. So if it's above, it's just obviously positive 10, below it's negative 10.
Yes.
Gotcha, easy. Okay, and then 37.
36 is different, just by the way. I mean, it's a backwards, it's going,
first.
Sure. Okay, so I have to draw a picture here so that it's clear what's happening here. The mu is right in the middle, and that's 100. And A, which we don't know, A is somewhere here, like maybe that's A, we don't know its value, but they're saying, and this is not to scale, they're saying that this area is 0.03. Okay, and the whole area under the curve is 1. So the area left of this center line is 0.5 left and 0.5 right. So this area again over here, not to scale, is 0.47, because 0.47 plus 0.03 is 0.05, which is this area on the left.
Gotcha.
So you're going to use inverse norm on your calculator. And I don't remember what the first, second, and third is, but it's some combination of like area, comma, mean, comma, sigma, comma, and then I think you have to choose like left, right, or between. But I don't really remember left, right.
Right.
So we want left this time because we know that A is here and 0.47 is left of A.
Okay, gotcha. Okay, yeah, so they give you, gotcha. And then we want left y again because that's on the left side. Gotcha.
You could do right, but you'd have to add 0.5 and 0.03 together. Again, there's like no way to do this one directly because it's slightly odd with it. But the picture could help. Like if you could just, visualize this, realize that that area is there. I think you'll be able to do it pretty quickly.
Yeah, that's not hard. Is there gonna be like, because I remember we did these a few sessions ago and we used right because we couldn't use left or something like that.
Right. Yeah. So that was like binomial stuff.
Oh, okay.
Which is not this, but
Gotcha.
You could use right here. I mean, do you want me to show you a problem where it would be right? Kind of like this, like
I
just
think it would be like something that was likely to come up.
so it would just look like this: 100 less than or equal to X less than or equal to B, and they tell you that that's 0.07. So this time the picture is, it's the same numbers. There's your mu equals 100, but this time the area over here, because B is to the right, there's B, and this area right here is the 0.07. So then this time you would want this area for your right. Your right this time is 0.43.
Gotcha. So, okay, so when I do right, I don't do the area they've given me. I do 1 minus that area.
No, it's got to be the area in the right tail, which is 0.43.
Yeah. So like the other one, the like given area was 0.03 and we use that in our thing, where it's like this one we wouldn't use the 0.07, you'd have to subtract 1.
0.5 from it.
Yes. Yeah.
Because it's in the right half.
Gotcha.
There's only a couple of variations on this, but we'll just assume that this is okay. Like this is probably what it's going to be.
Yeah.
All right, so now we can go to 37, I think was your question to do next. And I think I may have been like, oh, hey, how's your calculus? We can for sure use your calculator for this question. But you, like the way I read this, it's like you have to set it up first. So I'll show you how to set it up, like what you should write down.
Gotcha.
And then we'll go right to the calculator for the actual calculation. So the expected value of X is the integral. And this should have a letter next to it, f of x times x from a to b dx. And so what you're going to put in the calculator for your problem is you're going to go to math 9, which I think is fn int, and it's going to give you an integral symbol. You're going to use 0 and 1 because that's here. You're going to use this 3x squared because that's here, it's given, and then you multiply it by x dx. Now, I don't know if your calculator will take this. You may have to actually write 3x cubed. But this is how you're going to find the expected value. You have to multiply by x. If you don't, you'll get 1, and that will not be correct when you do this.
Okay, so when I put in 3x squared. Okay, so on my calculators, there's parentheses, obviously, in between.
Yeah.
Liberty of x. Does that, the multiplying, okay, there you go.
Yeah, like that.
Okay. I'd have to put double parentheses, huh, to get the 3x.
Again, I would probably multiply and just not like mess around parentheses. I mean, it's 3x cubed. I would just replace, I would go 3x cubed dx in your calculator.
Oh, so I don't have to do the whole top part?
No, but you have to know to multiply by x by hand and then put in your calculator the reduced form.
Okay, so just to clarify, so I write, like the top part is what I'd write on my paper.
Yes.
But the bottom part is what I'd put in my calculator.
Yes, this is a calculator. Yes.
Gotcha. And why did we add? Oh, because gotcha, the multiplication of the 3x. Gotcha. Okay.
Yeah, you just have to know where the stuff maps, like where these numbers come from. and then you'll be okay. So that's only expected value of X, okay? There's two other things that it's asking for. So there's this intermediate step here, which it's not asking for, but you have to do, which is the expected value of X squared. Okay, and you can go right to your calculator for that. It's 0 to 1, 3x cubed, because that's what you were given. This time it's times X squared instead of X. So in terms of what you put in your calculator, it's going to be 3x to the 5th dx.
Okay. The X squared, where did you do that again from? Like, why is it?
Because you need this intermediate value. You know, this is needed to do the next thing. You can't do the next thing.
So no matter what like number I get, I have to multiply it by X squared.
No, you're putting whatever function. You said number, and whatever this function is.
Yeah, that's.
Whatever. Yes.
Whatever function I have to multiply by X squared, no matter what.
Because so e of X you multiply by X, e of X squared you multiply by X squared.
Okay. Okay, gotcha. And then, okay, so that'll give me.
So did you get a number for that one? Because the first one is 0.75. Did you get a number for this one?
For the first one, I got 0.6. Oh, I see what I did wrong. Okay, I multiplied it like the second one by X. Okay.
Yeah, the second one is 0.6.
Go ahead and confuse is what I did here. Okay, so the first one I did the first one wrong.
Okay, so make sure for the first one, if you want to try again, make sure you get 0.75, because you really can't move on if
Okay, I don't. Oh, I keep putting. Okay, I see what I'm doing. Okay, gotcha. Okay, and then so the second one is 0.6.
Yes. Yeah, just make sure that also, you know, you see the number come in your calculator, because that's how you're going to do on the test. And you really won't have any way to know whether it's right or wrong. So you just got to be solid on, you know, your comfort level of doing that.
Okay. I guess to go back to the first part of it, the very first step, the 3x squared times x divided by 3x to the third.
No, you're not dividing. No. That's just me writing out what it simplifies to.
Okay, that's where I was confused. Gotcha.
And it's the same thing for this one. Like this becomes 3x to the 5th, and that's what, like, you want to write this and then put that in your calculator. I didn't make that that clear. This is the calculator line.
Okay. Makes sense. Okay, good on that one.
Okay. Do you have this number here?
Yes.
Okay. So here's why. I mean, because even reasons, hey Matthew, why do I need these? Because the formula for variance of X, which is the thing you're actually being asked to calculate, is the expected value of X squared minus the expected value of X squared. So you need those two numbers, your answer from part the expected value of X squared, that 0.6 minus 0.75 squared.
Gotcha. Okay. Okay, so I got 0.0375.
Okay, so that's your answer for the variance of X. And then the last one, the standard deviation of X, is the square root of the variance of X. So it's the square root of 0.0375.
Okay, gotcha. Okay, so 0.1936 or 0.194.
Sounds good. Sounds reasonable to me. Is there anything in this sequence that you would like us to go over again for this type of problem?
So okay, I guess just for clarification, the density function is just like, is it the whole thing that we just did, or?
Yeah, they have to give you the density function. They have to give you the density, like the density function leads to these three values.
I see. Okay.
So I even write that down here because you may want to see that, the density function, it has to be given. So there's two things that have to be given, the density function and then the bounds. And this leads to expected value of X, the intermediate step, expected value of X squared. Then the next thing they usually want, which is variance of X, and then the standard deviation of X.
Okay. And so for all, or maybe not all, but if the density function was like 5x to the third, would
Yes,
my second step lead me to like 5x to the fourth?
for expected value of X, yes.
Gotcha. Okay.
38 is somewhat different and it uses 37.
We don't have to, he said like,
Okay, good.
got
Because
rid of that
you
problem.
can't use your calculator with that one.
Yeah, he got rid of our problem
right.
for that one.
Okay. All right. What's next?
39.
All right. So you're gonna be really disappointed in this one. It's not even close to as difficult as the last couple. So maybe that's a good thing. All right. Assume that worker salaries in your company are uniformly distributed between $10,000 and $6,000 per year. So if we made a graph, okay, here's 10,000, not to scale, to 60,000. This question is asking for the average, the middle number. So it's simply an average of two numbers, 10,000 plus 60,000 over 2.
Oh,
So it's 35,000.
okay, that was beyond simple.
Yeah. Underwhelming.
I hope there's a lot of those on the test.
Yes.
Okay. Those are the ones I was most concerned about. 26 and 27. I think we might have gone over these the other day, but
Yeah, so 26 for sure you can use a calculator. 27 you cannot. So
how would I, so the calculator on 26,
Yep.
do I just put in obviously the bounds and then x d of x?
Yep, it's 0 to 2 because of this. It's x because of this, and then dx. And what you're hoping for is, does this equal 1? Because if it equals 1, then you can say yes. If it does not equal 1, then you can say no.
Okay, so what is the yes and no for?
If it equals 1, you're going to put this in your calculator.
Well, yeah. Is it like a question that I'm answering?
Yeah, you're going to get a number.
Does it admit that?
Yeah. Yeah. This is strange. Admits. Huh.
So if it's gotcha, simple.
And you'll find that it does equal 2. But you should definitely confirm that if you're unsure.
Okay. That one's simple.
Yes.
27.
27. All right. This one, let's see here. So if you were given the value of k, you would just put this in your calculator. Okay, because the bounds are from 0 to k. 5x goes here, dx.
Okay.
So the problem is, though, is you can't do this like this. There's no direct calculator thing here for this one. So you have to actually use some calculus for this.
Lovely.
Would you like us to continue going through it?
Yes.
Okay. So first thing to make this as simple as possible is we're going to move the 5 out. So it's 5 integral 0 to k x dx.
Okay.
So now off here to the right is the definition. The integral of x to the n dx is always x to the n plus 1 over n plus 1. In your case, n is 1. Like your exponent is 1. So all of this right here becomes x to the 1 plus 1 over 1 plus 1, and then you bring the 5 down.
Okay. Gotcha.
So we're not quite done yet, but like is everything okay so far?
Yes.
Okay, so this simplifies to 5 halves x squared, but then you evaluate it from 0 to k.
Okay.
Let's assume that this number is always 0, even in the one you're going to get. You just take this k and you put it in for x. So it becomes 5 halves x, I'm sorry, k squared. And if this is a probability density function, which it is, like it's supposed to be, then this is supposed to equal 1. Okay, so if this is still okay, you have to now solve for k.
Okay.
So you solve for k by multiplying both sides by 2/5. Okay, so you get k squared equals 2/5, and then k equals the square root of 2/5,
Gotcha.
which is some number. So to be like kind of to be totally clear here, you use the calculus, which is only one step, to come up with an equation that you're always setting equal to 1 because it's a probability density function. Like this thing equals 1 from the beginning. You just can't use it until you get to that place where you can put k in.
Okay, I see. So like you said, if k were to equal 1, it would be a density function, and if it
No.
not it's obviously not.
No, the area, the area, the area, the integral, not k. K is just a number. It's an upper bound.
Oh, I see.
Yeah.
Okay.
So like that you could, here's what you could do, which I don't think would work because it would take too long, but you could do fn int, okay? And in your calculator, you could just start picking values up here. You could put numbers up here until this equals 1.
I see.
But that, like, I don't know how good your guessing is, but you could do that.
That would be like if I couldn't figure out the equation, that's what I'd be doing.
Yeah.
Okay. Gotcha. And then after I get k, I just put those numbers into the integral and figure it out.
Yeah.
Okay, easy. Not too bad. Okay, those are good to go. Number 22.
Here, okay. Yeah, okay, so this one is asking you to find the mean and the standard deviation. And I guess, again, you probably have to show some work here for this. So X bar is the mean for.
Wait, I meant 23, but you're using question 22.
Okay. But do you know how to find the mean and standard deviation of these?
Yeah, he got rid of those questions.
Okay, so can you just from the answer sheet, can you give me the mean and the standard deviation for the next ones? I guess I've got them too. Sorry, I guess I can go look. I'm being lazy.
22, the mean is 5 and the standard deviation is 0.6.
Okay. So question 23 is asking, we'll just do it in pieces here. Using the empirical rule. So the empirical rule says that 95% of the data falls within 2 standard deviations. So it's like X bar plus 2S. and then X bar minus 2S. And within this window is 95%.
Okay.
So you have to do 5 minus 2 times 0.6, comma 5 plus 2 times 0.6. So that's like 3.8, comma 6.2.
Okay. Gotcha. And is that?
That's it for A. For part B,
Oh, gotcha.
for part B, it's saying, well, okay, great. You've given me the numbers, but like how much of the actual data falls in this window? So let me snip in the data, and all we're trying to decide is like yes or no. Is each number in this window from 3.8 to 6.2? So yes, 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 and yes. So 100% of the data. So let's say this last number was like 9.9 and it was a no, it would obviously be like 80%.
Okay, gotcha.
Part C is quite awkward because up until now you have not talked about Chebyshevs. I don't know why this guy gets so much credit. He's, at least in textbooks, they sort of go over this. So he says that the percent of data is follows this formula: 1 minus 1 over k squared, where k is the number of standard deviations. So in your case, k is 2 because it's like 2 standard deviations. So he would say 1 over 1 minus 2 squared, which is 0.75. So he would say 75% of the data is within 2 standard deviations. But we just said that, we just said in this previous part that 100% of the data actually falls within 2 standard deviations. So it's asking you to compare the empirical rule, which was 95% versus 75%, and then saying like, which is better? And
Okay.
it's the empirical rule.
Gotcha.
It's probably a good question, but not what this data said. So, I mean, if you understood the empirical rule, which is 2 standard deviations for 95%, that's probably what's going to be asked, if anything. This one's a little more specific. You have to know this formula.
I don't even remember him. Like, I don't even think he ever even brought that up throughout
Right.
the whole semester.
Right.
But yeah, okay, that's simple. The empirical rule. Gotcha. Okay.
Anything else you'd like us to look at?
24.
24. It's referring to question 20. Oh. All right, it says, assume that, okay, it wants you to, 24 is referring back to question 20. It's saying like, figure these out. So these are this is 0.2 and 0.2. And I know that because these all have to add up. This row has to sum to 1. And it tells you that they're equal.
Okay.
So if that's not clear, you would put X there. You would say like X plus 0.4 plus 0.1 plus 0.1 equals 1. And that leads you to X equals 0.2. But this problem is asking about finding the standard deviation from the table.
Okay.
Okay, so what I'm gonna do here is just snip the table down because I actually don't care about anything else after we get the values in the table. Like you could get a problem that asks for the standard deviation that just from the table. So it's a general recipe for this. So it does say, hey, you got to find expected value first, and you know that because we already did that up here in a bunch of these problems. Remember, we found expected value X squared, variance of X, and standard deviation of X.
Mm-hmm.
And that's the order we have to do this down here. It's
Gotcha.
not that difficult, but it's got some steps here. So expected value of X, you take the X value and you multiply it by P of X. So that's -2 times 0.2 plus -1 times 0.2 plus 0 times 0.4 plus 1 times 0.1 plus 2 times 0.1. So you just multiply these numbers together.
Okay. Gotcha.
Do you have a number for that?
1 second.
Okay.
This just takes forever to like enter in.
Yeah, I know what you mean.
Okay. I got -0.3.
Okay, that sounds reasonable. All right, so now, as I mentioned above, you have to do this like intermediate step of the expected value of x squared. So all you're doing, and it's not, it's really not any more difficult than this, but you have to square that first number. You're squaring the values in the x row. So that's times 0.2 plus -1 squared times 0.2 plus 0 squared times 0.4 plus 1 squared times 0.1 plus 2 squared times 0.1. And once we get these two values, you can pretty quickly get the variance and standard deviation.
Oof, this one just takes even longer to put in.
Yeah. Just be careful that you're putting it in parentheses. But this is like 0.8 plus 0.2 plus 0. So I get 1.5 for that.
Yeah.
So your variance of x is the expected value of x squared minus the expected value of x. That's why you had to find these two values. It's 1.5 minus -0.3 squared. So that's like 1.41, I think. Let me check that.
Okay.
And then the standard deviation of x is the square root of the variance of x, which is the square root of 1.41.
Gotcha. So it's just like same thing as we did.
Yeah, yeah. The order here does matter. If you put these in the wrong order, the expected value of x squared and expected value of x squared, sorry, you will get a negative number. And standard deviation variance is never negative. Standard deviation is never negative. So that's just, make sure you got this formula down as well.
Okay. So I like quick calculator question, because I know for like some of these you could like put them into your I mean by hand it's not hard either, but can't you can put it into like the one.
I've heard that you can put it into L1 and L2, and then you can do some stats on it. I don't really know right offhand. I mean, I can look into that.
Well, my thing was is like I know how to like enter it, but my like when I go to put it on one of our stats, like how do I like how do I list L2 on my calculator? Because it's not there.
Yeah, it's because you've got to do like something with the two. It's something.
Because I like deleted it one time just to get the list for L1, and I don't know how to get it back.
Yeah, I'm not sure. I'm looking right now and trying to see if
It's
I can.
right here. It's just second number 2 when it comes back. Okay.
Okay.
Yeah, because then that gives me all those numbers. Well, yeah. And then standard deviation, is that the sigma x?
They're slightly different. So S is the sample standard deviation. And your instructor seems to be very good at like saying S. Sigma is the population standard deviation.
Okay.
They are not interchangeable, but you may not have an issue on this exam if you just ignore the difference between them.
Okay.
But there is truly a difference between them, which you would see in the next, like a stats class or like an econ 211 you might be taking.
Because it gives me sigma x, but doesn't give me like sx.
So you want, well, that's why I said, so it gives you sigma, I'm sorry, that one's here, and then it gives you big SX in your calculator when you do your one var stats. Let me see if I can snip in a picture of one that has this done to show you. Yeah, so here, let me snip this in. Just found this from a guy, person online. So the SX is this one, this row, and then the sigma x is the other one.
Gotcha. Easy. Let me see if I have anything. Maybe number 8. Or honestly, probably 11 first.
Number 11, you said?
Yeah.
Okay. All right. Let X be the upper number when 2 dice are rolled, or the common number if doubles are rolled. Okay, so there. And I gotta grab a 2 dice sample space image here so that we can do this. Here's a good one. All right. So the table is pretty helpful because they're kind of cluing you into what, like they don't give you extra spaces here. So it's basically the bigger number of the two that you might see in the roll. Okay, so the bigger number is going to be the numbers 1, 2, 3, 4, 5, and 6. Okay, and now we'll just go we'll go through a row here, or I'll go through a column here so you can see which. I actually don't like that one. Let me see if I can find a different sample space. This one is better. It's awkward when it's going the wrong direction that we read. All right. So in this first column here, and we're going to just use tallies. You get a 1 and 1, that's 1. 2 and 1, 2 is the bigger number, so you put a 2, and then 3 and 1 there, 4 and 1 there, 5 and 1 there, and 6 and 1 there. Okay. Now here's where maybe it gets more interesting. So the 2 is the bigger one in the first one, and then 2 is the bigger one in the second one, but then 3, 4, 5, and 6 are the bigger ones.
Oh.
Now in this one, 3 is the bigger one in the first 3 because it matches. So you go 1, 2, 5, and then you get 4, 5, and 6 on that. And then the next one here, 4 is the bigger one for the first 4. So that's 1, 2, 3, 4. And then you get 5 and 6. So we'll add tallies there.
Gotcha.
And then 5 is the bigger one all the way up to 5. So 1, 2, 3, 4, 5. And then 6 gets another one there. And then 6 is the bigger one in all of these. So you get 1, 2, 3, 4, 5, 6. Okay. So now you just count. So it's 1 out of 36, 3 out of 36, which reduces 5 out of 36, 7 out of 36, 9 out of 36. Maybe you see a pattern, 11 out of 36. If we've done this correctly, then all of these add up to 1. So 1 plus 3 is 4, plus 5 is 9, 16, 25, 36 out of 36, it works.
Gotcha. I'm hoping he doesn't give stuff like this on the test because I feel like you need like charts to figure it out, kind of.
You sure do. It's a little bit more time consuming, but obviously I can't speak to that. I don't have a copy of the exam. Do you still want us to go through number 12?
We did 12 last time. That one was pretty easy, but I think the only one I left was number 8, and that was about it.
You said 8 here. Okay. Oh yeah, this one was really complicated. It's weird. We got to use a tree diagram for this one. So the main one here is setting this up. I remember maybe even doing a WebAssign with you where it was just odd. Okay, so professor insists all senior majors take his physics test. Fail the test. 9% of majors go on to career in physics. Okay. I gotta figure out the tree here, which is there's something here. Okay, so take and don't take. Not sure of that. So 100% take it, 0 don't take it. 40% of the seniors that go on to a career in physics. Okay, so still fail the test. Okay. Okay, yeah, this one's a little weird. So the first one here is you have a career in physics or you don't, I think. So those who have a career in physics, it says here 40% of the seniors who go on to career in physics still fail the test. Oh no, furthermore, all senior physics. Okay. Yeah, so this is so awkward. All right, let me move this up slightly so we can see all the numbers here. Once we get the numbers, it's very straightforward. So career in physics, don't have a career in physics, and then pass, and then fail, pass, and then fail. Okay. So now we can actually use 40% of the seniors who go on to a career in physics still fail the test. So that's over here. So we assume 60% pass. 95% of all physics majors go on to a career in physics. That's point here. That's up here, point. So you're starting out with physics majors, and this is like all physics majors, and they either go on to a career in physics or they don't go on to a career in physics. Okay, and you might think, well, how do we do this side down here? Well, it says in the first sentence, it's so tough that anyone not going into a career in physics has no hope of passing. So if you don't go into a career in physics, you will fail 100% of the time and pass 0% of the time. I think there's almost no chance you're going to get this type of question on your exam, but because it's so hard to set up. But now that you've set it up, we can actually answer the question: what is the probability that you will not go on to a career in physics? Okay. Oh, well, that's the 0.05. Oh, I'm sorry. Assuming you fail the test. I didn't see that part. Assuming you fail the test. So there's two paths to fail. There's this one on the left, 0.95 times 0.6 plus 0.05 times 0. There's two, I'm sorry, times 1. So there's, I gave you the wrong numbers here. Sorry. That's 0.4. We want the ones down the left and fail, down the right and fail. Okay, and then we want the probability that will not go on to a career in physics. That's this one on the right. I mentioned this to you before. There's always whatever's in the numerator comes from one of the answers in the denominator.
Gotcha. Okay, that one's easy. I just didn't know how to set that one up. That was the confusion I had on that.
Very tough. It's encoded in a lot of the sentence where you don't seem to have enough numbers.
Yeah.
Like that.
That was easy.
All right. Hey, I'm gonna just stop sharing real quick. Got just a small administrative thing to just talk to you about. So yesterday I got you the refunds for both of the lessons the ones you had scheduled, canceled, and then rescheduled that I had missed. But nothing for today. So if you're okay with this, I'd like to just invoice the K Simone email and send off the invoice for today's lesson.
Perfect.
Will that work?
Yes.
Excellent. Okay. Thank you so much for scheduling and working with me this semester. If you need help in the future, please let me know.
Gotcha. Thank you very much.
You're welcome. Have a great day. Bye now.
Bye.